Hi, this is the Science Chef. You're welcome to another edition of our 2023 JAMB Preparations series. Today we'll be answering more questions on the periodic table. If you'd like to watch our tutorials on the past 6 series, kindly check the links in the description. Alright, let's start. Question 1. A decrease in atomic size and an increase in nuclear charge across a period leads to. This question is on atomic properties and the periodicity of atomic properties. A decrease in atomic size and an increase in nuclear charge across a period leads to what? Now, these are the factors that affect the variation of atomic properties on the periodic table across the period and down the group. Now, what are those factors? In our last video, we talked about them briefly. Let's throw more light on them here. 1. Factors affecting what? Periodicity of atomic properties. 1. Effective nuclear charge, which is the number of protons in the nucleus of the atom. 2. The shielding effect of inner electrons. The shielding effect of inner electrons. And 3. The distance of the outermost shell from the nucleus, otherwise called atomic radius or size. Now, the effective nuclear charge increases across the period because as you move across the period, electrons are being added to the same shell. And electrons are being added to the same shell, the number of protons in the nucleus of the atom also what? Increases. And as the number of protons increases, the effective nuclear charge increases. The shielding effect of the inner electrons remain relatively what? The same, because electrons are added to the same shell. So the inner electrons do not change. The total number of shells across the period remains the same. Let's say period 3, for example. All the elements in period 3 have 3 shells. But as you move from sodium to chlorine, the number of electrons in the outermost shell increases by 1 successively. Now, the number of inner shell electrons remain the same, from 281 to 287. So from sodium, which has 11 electrons, with 10 inner electrons, to chlorine, which has 17 electrons, with also 10 inner electrons. So the shielding effect of inner electrons remain relatively what? The same. Now, as you move from sodium to chlorine across the period, the distance of the outermost shell from the nucleus becomes what? Smaller, because of the increase in the nuclear force of attraction. There are 2 major forces that always act against each other in an atom. One is the nuclear force of attraction, and the second is the electron repulsion. Now, the nuclear force of attraction acts between the nucleus and the outermost shell, whereas the electron repulsion is the shielding effect of the inner electrons on the outermost electrons. So if the inner electrons remain relatively the same as you move across the period, then it means that the electron repulsion remains relatively the same. But as the number of protons or the effective nuclear charge increases, it means that the nuclear force of attraction increases tremendously as you move from left to right across the period. And because of that increase in the nuclear force of attraction, the outermost shell will be greatly pulled inward or closer to the nucleus as you move from sodium to chlorine. That's taking period 3 as an example. So because of that, there will be an increase in the tendency of an atom to attract electrons to itself. There will be an increase in the electronegativity of that atom. Then there will be a decrease in the tendency of an atom to lose it because of the very strong nuclear force of attraction between the nucleus and the outermost electrons. Because for that atom to lose an electron, that force of attraction will have to be what? Overcome, right? And most times it's always difficult to overcome that force of attraction as you move across the period, which is why nonmetals tend to have a higher ionization energy compared to metals, because ionization energy has to do with the energy required to remove an electron from the valence shell of an atom. So given that, what will be the answer to this question? So a decrease in atomic size and an increase in nuclear charge across a period leads to A, an increase in the tendency to lose electrons. That is not correct. B, an increase in chemical reactivity. That is not correct too. A decrease in electropositivity. That seems correct, but let's look at the last option. A decrease in covalency in bond formation. The most appropriate answer here is C, a decrease in electropositivity. Electropositivity is the ability or the tendency of an atom to lose electrons. And as you move across the period, right, the decrease in atomic size and an increase in the nuclear charge, which leads to an increase in nuclear force of attraction, decreases that tendency for an atom to lose electron. Rather, it increases the tendency for the atom to gain electrons. So the answer is option C, a decrease in electropositivity. Question 2. In the periodic table, electrical and thermal conductivities are properties of elements that A, decrease across the period and increase down the group, B, increase across the period and decrease down the group, C, decrease across the period and down the group, D, increase across the period and down the group. This question is still on the periodicity of atomic properties, and the three properties we are considering here are electrical and thermal conductivities. Electrical and thermal conductivities are metallic characters or metallic properties, and on the periodic table, as you move from left to right across the period, there's always a decrease in the metallic characters or the metallic properties because you are moving away from metals to the non-metals. The metals are always found on the left side of the periodic table, the middle and on the left side of the periodic table, while the non-metals are found on the right side of the periodic table. So as you move from left to right, there is always a decrease in metallic characters or metallic properties. You move away from metals to non-metals. So since electrical and thermal conductivities are metallic characters, then there will be a decrease in these properties across the period. But note that metallic characters or metallic properties decrease across the period in the periodic table and increase down the group, which means that as you move down the group, the metallic characters increase. But if you move across the period, metallic characters decrease. So if you apply that principle here, electrical and thermal conductivities being metallic characters or metallic properties will decrease across the period and increase down the group. And the answer is what? A. Before we pick our answer, why are we saying that electrical and thermal conductivities are metallic characters? Electrical and thermal conductivity are metallic properties or characters because it is only metals that can conduct electricity. Metals have the ability to conduct electricity, apart from graphite, which is the only non-metallic substance that can also conduct electricity in its pure form, right? Metals conduct electricity due to the presence of free mobile electrons in their metallic lattice, right? So the answer is A. Question 3. That is obtained by measuring the distance between the center of one ion and the center of its nearest neighbor of opposite charge. The distance between the center of one ion and the center of its nearest neighbor of opposite charge. For the fact that we're talking about an ion and an oppositely charged neighbor, they're talking about two ions or an ionic structure, right? So if you have a copper, let's say a positive ion here and a negative ion. So what we are saying is the distance between the center of this positive ion and the center of this negative ion is what we are looking for. And what is that called? It is called what? The ionic radius. That's the size of the what? Ion, right? So an atomic radius now. Atomic radius is simply half the distance between the centers or nuclei of two covalently bonded atoms, right? So since these ones are not covalently bonded, so that's why it is called ionic radius. But if they were covalently bonded, something like this distance will be what? Atomic radius. That's half this distance will be what? Atomic radius. Then mass radius, I don't know what mass radius is. And then D, atomic number. For the atomic number, the number of protons present in the nucleus of an atom. So the answer to this question is A, ionic radius. Question 4. Metals of the first transition series have special properties which are different from those of group 1 and 2 elements because they have partially filled. First of, what's the transition metal or what's the transition element? A transition element is any element with partially filled d orbitals, and the members of the first transition series include scandium from scandium 21 to zinc through chromium 24, manganese 25 up to copper 29, and then zinc 30. These are the members of the first transition series from scandium to zinc. right? We have some other metals in between, like titanium, vanadium, iron, nickel, cobalt, and co. Fine. So not all these elements or metals are actually transition metals. It's only those that have partially filled d orbitals, which is why zinc is not considered as a transition metal, because zinc has a completely filled d orbital. That's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10, completely filled what? D orbitals. So zinc is not a transition element, which is why its salts are always what, or its compounds are always white or colorless in what solution, right? The only property that zinc shares with other transition elements is the ability to form complex ions. Now, talking about the properties of transition elements, they exhibit variable oxidation state, right? At least more than one of its oxidation state will be what? Stable. They form colored compounds, and they form colored ions in solution, and they have the ability to form what? Complex ions formation, and they have a catalytic ability. They have catalytic ability, and they are also paramagnetic. So these are some of the properties of transition metals that you are expected to know in your syllabus, right? Apart from the complex ions formation, all these properties are basically due to the presence of partially filled d orbitals, right? So going back to our question, I told that metals of the first transition series have special properties which are different from those of group 1 and group 2 elements, because they have partially filled what? D orbitals. And the answer is what? C. Number 5, transition metals possess variable oxidation states because they have, well, we've just treated that already, but they have electrons in the d orbitals. So let's not waste our time on that. That's what? Option B. Question 6. Which of the following properties increases from left to right along the period but decreases down the group in the periodic table? A. Atomic number. Atomic number increases from left to right across the period in the periodic table, and it also increases down the group from top to bottom. Yes. So it's not atomic number. Atomic number and mass numbers are the two properties that increase across the period and down the group. Ionization energy. Ionization energy is the energy required to remove 1 mole of valence electron from the outer shell of an atom, and it is a function of the atomic radius of the atom or atomic radius of the what? Element. The smaller the atomic radius, the greater the ionization energy. And we know that atomic radius decreases across the period. We already answered a question on this, I think the first 2 or 3 questions. Atomic radius decreases across the period due to an increasing what? Nuclear force of attraction between the nucleus and the outermost shells, or the nucleus and the outermost electrons, right? So that force of attraction has to be overcome before any electron in the outermost shell can be removed, which is why ionization energy increases across the period. But if you go down the group, there is an increase in the size of the atoms. Electrons are being added to new shells, and because electrons are being added to new shells, even though there's a corresponding increase in the atomic number or the number of protons, the larger size of the atoms as you go down the group counteracts or overpowers the nuclear force of what? Attraction, right? So even though there will be a kind of attraction between the nucleus and the outermost electron, the increase in the number of inner electrons will reduce the effect of that attraction, thereby making the atomic radius to be what? Bigger as you go down the group compared to moving across the period from left to right. Metallic character. Metallic character decreases across the period because as you move from left to right, you are moving away from metallic to non-metallic what? Properties. So metallic character decreases across the period and increases down the group. We've done that already. Then electron affinity. Electron affinity has a similar trend to ionization energy. Electron affinity is the energy released when an electron is added to a gaseous atom to form a gaseous ion. So for that to happen, remember the electron you are adding is negatively charged, while the electrons that are already present in the atom are also what? Negatively charged. So there will be a kind of what? Repulsion between the existing electrons in the atom and the incoming electron. So for that electron to be accepted into the atom, it must overcome the electron what? Repulsion, which is the form of energy that will be what? Released to overcome the electron what? Repulsion. So that property also increases across the period and decreases down the group. In other words, ionization energy, electron affinity, and electronegativity, and of course metallic character, all these guys increase across the period. They increase across the period, but do what? Decrease down the group. They increase across the period and do what? Decrease down the group. So that's the trend for these properties. Well, the atomic radius decreases across the period and increases down the group. All right, so what would be the answer to this question? Which of the following properties increases from left to right along the period but decreases down the group? Ionization energy, yes. Metallic character, yes. Electron affinity, yes. 2, 3, and 4. 2, 3, and 4. There's no 2, 3, and 4 here. So there's no answer here. So let's move to the next question. The correct answer ought to be 2, 3, and 4. That's the correct answer. There's no answer here. But under an exam condition, what would you do? I would advise you go for this and this. That's 2 and 4. Because much emphasis is always laid on metallic character as a typical atomic property, right? Like ionization energy, electron affinity, atomic radius, electronegativity, and co. Metallic character is always used as a collective property of metallic properties. So in that case, I would say probably we can go for 2 and 4. Is there 2 and 4 here? That's option D. But if there were 2, 3, and 4, then the answer would have been 2, 3, and 4. So let's go for option D. Question 7. Which of the letters indicates element which exists as diatomic gases? We've treated this question before. Yes, we treated it in our last tutorial, so we are not going to waste time on this. We took time to explain the answer to this question. The two elements here that are diatomic are F and A. All group 7 elements are diatomic molecules, but not all of them are gases, right? But since we are told diatomic gases, right? We also have oxygen in group 6, which is also diatomic, a diatomic gas, and nitrogen in group 5, which is also a diatomic gas, and hydrogen in group 1, a diatomic gas. But since there is nothing in group 5 and group 6, so we have only group 1 and group 7 here. So that is, and this F here is chlorine. So the answer is what? A and F, which is option D. Question 8. The ability of an atom to attract electrons toward itself is called, we already explained this, ability to attract electrons toward itself is called electronegativity. So we won't waste time on this. Yes, while the opposite is electropositivity. Electronegativity is a measure of the reactivity of non-metals, while electropositivity is a measure of the reactivity of metals, right? Electron affinity is an energy. I've already explained that in the last 2 questions. Likewise, ionization energy. While electron affinity is the energy released when an electron is being added to a gaseous atom to form a gaseous ion. Ionization energy, on the other hand, is the energy that is absorbed, taken in, or required to remove a valence electron from a gaseous atom to form a positive gaseous ion. So the answer to this question is option B, which is electronegativity. Question 9. The alkali earth metals have a valency of. The alkali earth metals are group 2 elements. Alkali earth metals. And because they are in group 2, means that they have what? 2 valence what? Electrons. And since they have 2 valence electrons, then their valency is also what? Equal to 2, because they need to give out 2 electrons in order to attain stable configuration. Remember, valency is the number of electrons the atom of an element needs to lose or gain in order to attain what? A stable configuration. So other common families of elements are group 1, which are known as what? Alkali metals, because of the ability to react vigorously in water to form alkali solutions. And they have 1 valence electron and a valency of what? 1. Then we have group 7, which are the halogens. Halogens mean what? Salt formers. And they are salt formers because they combine readily with metals to form salt. And they have 7 valence electrons, and their common valency is, then we have groups 0, that's the noble gases. And these ones have what? 8 valence electrons, and they have a valency of what? 0. They have a valency of 0 because they don't need any electron. They need to lose or gain any electron. They are already the royalties of the elements. So that's why their valence is what? 0. So the answer to this question is what? The alkali earth metals have a valency of 2, which is option B. The last question, question 10. A common characteristic between zinc and the other transition elements is the ability to. I already answered this question when I was answering the first question on transition metals in this series. So I told you that the only property that zinc shares, or characteristic that zinc shares with other transition elements, is the ability to form complex ion. That's the only characteristic that justifies its position in that D block. Apart from that, zinc is not meant to be a transition element. So the answer to this question is what? Option B, to form complex ions. So that brings us to the end of our tutorial for today. If you had learned anything from this tutorial, kindly drop your comment, subscribe to this channel, and hit the like buttons, especially if this is your first time here, in order to stay updated with our new upload. Remember, it is never over until it's over. So keep fighting and don't give up until I see you when I'll see you.